Okay, today we're going to talk about the factor theorem. If P of C is equal to 0, means when you plug in C and you get 0 for your answer, then x minus C is a factor of your polynomial. And also the reverse is true. If you divide by x minus C, or if x minus C is a factor, then when you plug in C, you will get 0. So using that factor theorem, if we know that x minus 1 is a factor, if you divide by 1, you should get 0. So looking at this one, if we divide by 1, we're going to have our coefficients of 1, negative 5, 2, and negative 2. So when we drop the first term, it's 1. 1 times 1 is 1. Add is negative 4. Multiply is negative 4. Add is negative 2. Multiply is negative 2. And your remainder is negative 4. That's not 0, which means that x minus 1 is not a factor. If you get 0 as a remainder, then it would be a factor. We go down to building using the factor theorem. If these are zeros of the function, that means that when you put them into polynomial notation, each one of those would be a factor. So x minus 2 would be a factor, x minus square root of 5, and x minus a negative square root of 5, which is x plus square root of 5. Now this is just one example of a polynomial that would work. This obviously we could have an a value out here of anything. It could be 1, 2, 3. We're going to make our lives easier just by saying that that's 1. So if you multiply all that back together, I'm going to put the two together that have the square root because that's easiest. When you FOIL that together, x times x is x squared. Outside is positive square root of 5x, inside is negative square root of 5x, that's gone. And the last term, negative times a positive is a negative, square root of 5 times square root of 5 is 5. Now if you FOIL these two together, first is x cubed, inside is minus 2x squared, outside is negative 5x, and last is plus 10. And that would be one example of a polynomial if your a is equal to 1 with those three zeros. Now for finding zeros using the factor theorem, say negative 4 is a 0 and you want to have all the other zeros listed, negative 4 should be able to go into this polynomial with a remainder of 0. So our coefficients are 1, 5, negative 45, and negative 36. We should get a 0 on the end if this actually is a 0. So you drop the first term, multiply, add, multiply, add, multiply, add, multiply, and yes, it is a 0 of the function. That means x minus 4 is one of the factors. The rest of this here is another factor, which if you put your variables back in is x cubed plus x squared minus 9x minus 9. Now, since it's down to a cubic and this is 4 terms, we can continue factoring using factor by grouping. In the first two terms, we have a x squared is common to both, which would leave you x plus 1. In the second two terms, negative 9 is common, which leaves you the same factor of x plus 1. If you regroup these, x plus 1 is common to both of those, leaves you an x squared minus 9. If you continue factoring, you're going to have x plus 1, and then x squared minus 9 goes to x plus 3 times x minus 3. And we started with our original x minus 4. So if we're asked for the zeros of this function, the original one that we were already given, was an x plus 4 as a factor, would be negative 4. And then the 3 that you have just found would be negative 1, positive 3, and negative 3 would be the last two. So those are your four zeros for your function of an x to the 4th function.